Boa noite, oficialmente, então, pessoal, todos que estão na sala. Estamos muito contentes de estar promovendo esse webinar hoje. Eu vou passar primeiro o programa de hoje, né, com vocês. Então, Roberta e eu estamos fazendo, né, dando as boas-vindas. Depois disso, o professor Jefferson vai falar um pouco da durabilidade no cenário, no contexto nacional. E logo em seguida já entra a fala do Dr. George R, ok? Sobre durabilidade de geomembranas de polietileno. Antes de passar a palavra para o professor Jefferson, eu vou trazer uma breve mensagem do Grupo Nortène. Aqui tem a nossa proposta de valor, né? Que é uma frase curta, mas que tem muitas nuances, muitos conceitos aí embutidos nessa frase, né? Que é proteger mais. Proteger o quê, né? Proteger as pessoas, proteger o meio ambiente, proteger o investimento que os clientes fazem adquirindo as nossas soluções, produzir melhor os nossos produtos, proporcionar para os clientes que eles produzam melhor, adquirindo, né, as nossas soluções, proporcionar que eles tenham projetos mais eficientes e com responsabilidade. Responsabilidade social, responsabilidade ambiental, responsabilidade em todos os âmbitos do relacionamento que nós temos com os nossos parceiros, principalmente com os nossos clientes. Essa proposta de valor, ela está ligada e como resultado, traz esses benefícios para quem se relaciona com o Grupo Nortène, que é a recorrência. Então, 92% dos nossos clientes estão conosco há mais de uma década. Mais de 75% da nossa equipe de especialistas está conosco, trabalhando conosco há mais de 5 anos. Isso resulta num atendimento otimizado, um atendimento colaborativo, personalizado, e resulta em negociações mais favoráveis para todo mundo que está envolvido. O segundo benefício é todo mundo usa, né? O Grupo Nortène, como líder de mercado, é referência no setor. Nós atuamos direta e indiretamente na cadeia toda, nos instaladores, com projetistas, com parceiros comerciais, e trabalhamos para entregar produtos confiáveis. E os especialistas, né, que é um time, somos um time que atua desde a pré-venda até a pós-venda. É um grupo que tem uma abrangência, né, uma abrangência muito grande de conhecimento, proporciona um suporte técnico especializado, personalizado, e cujo objetivo é que os clientes obtenham o máximo, né, do desempenho das soluções que a gente entrega. Gerando, né, também relacionamento de confiança com os clientes. Todos esses benefícios resultam em mais segurança, mais lucratividade e mais produtividade para os nossos clientes. Falando, né, em especialistas, então aqui eu apresento para vocês o nosso time de engenharia em ação, que faz toda essa parte de suporte técnico. E tem dois braços, está dividido em dois grandes braços, né? O braço do agronegócio e o braço da proteção ambiental, que é quem está promovendo esse webinar hoje. Ainda dentro desses grandes braços, também estão dispostos os produtos, né? A nossa linha de produtos. Então, no braço do meio ambiente, nós temos os geossintéticos, né? A polimanta, lisa texturizada e HP. A linha de geocompostos drenante, Nordren. O geocomposto vertical, Tecdren. Os nossos acessórios para instalação de geomembrana, fio de solda, aporte e inserto em gelock. E a rede de instaladores parceiros que faz a instalação desses geossintéticos. E, para finalizar, o braço do agronegócio, que tem a polimanta agro, que é a geomembrana específica para aplicações hidráulicas, né, em canais e reservatórios de água. silo, bolsa, silox, silagem, filmes e mulching, telas e mangueiras de irrigação. Eu finalizo aqui a mensagem, né, que eu tinha para dar, e passo a palavra para o professor Jefferson, né? Boa noite, professor Jefferson, bem-vindo.
Boa noite.
Muito bom tê-lo conosco essa noite. Eu vou tirar minha tela aqui para que tu possa compartilhar, ok?
Tá bom.
Então, bom evento para todos, aproveitem, o conteúdo tá ótimo. Deixa eu parar aqui.
Então, deixa eu ver se eu consigo.
Stop.
Ok. Você consegue ver minha tela aí?
Sim.
Sim? Só
Sim.
que eu não estou conseguindo ver, mas deixa eu ver aqui como eu faço para ver a tela. Tá vendo ela em...
Não tá em modo cheio. Agora sim, modo cheio.
Tá muito cheio? Ok. Então, eu quero inicialmente agradecer o convite da Nortène, da Ingepol. Eu fiquei muito honrado com o convite de estar juntamente com o Dr. George Koerner. Eu acho até que esse título veio bem a calhar, mas não pela minha, né, pela minha participação em si, pela dele. Acho que a gente vai ter uma excelente palestra, né? Então, o objetivo que a Nortène, a Gepol me deu foi de falar um pouquinho, né, sobre a questão das geomembranas no Brasil. A gente, na verdade, tem muita coisa para falar, né, sobre diversos aspectos. E, inicialmente, eu queria trazer um pouco sobre o laboratório de geossintéticos, que é onde a gente atua, né? Então, esse laboratório ele tem mais de 20 anos, e foi o professor pioneiro, o professor Benedito, que leva o nome dele, Benedito Bueno, e nesse laboratório a gente executa pesquisas e outras tantas atividades que eu vou comentar ao longo da minha apresentação. Então, aqui dentre as atividades que a gente realiza aqui no laboratório está o principal objetivo é ensino e pesquisa, né? Então a gente atua na transferência de conhecimento e na realização de pesquisas que dão base para alguns trabalhos em geossintéticos em geral. A gente também desenvolve um trabalho importante sobre os ensaios de laboratório, tanto para as academias, né, para as co-irmãs, como também para algumas obras de geossintéticos no Brasil e para as próprias fabricantes, no caso da Nortène, né, que a gente está tratando hoje. Desenvolvemos também a questão dos cursos de treinamento, né? Esses cursos de treinamento eles são direcionados a um público específico, como algumas empresas ou no caso do nosso curso atual, um curso de difusão onde a gente abre para toda a sociedade, né? Então a gente tem alguns cursos sobre geossintéticos, inclusive sobre geomembranas, e também nós atuamos na consultoria e nos serviços de campo, quando a gente aborda alguns serviços que são, alguns deles, com geomembranas, em aterros sanitários e assim sucessivamente. Então, qual é o geossintético, né, mais utilizado no Brasil? E aí eu lembro da palestra da professora Delma no ano passado, quando o laboratório fez 20 anos, né? Ela fez um relato muito importante sobre o futuro de geossintético no Brasil, e ela trouxe alguns números para nós, abordando principalmente a contribuição, no caso, né, da geomembrana, como um principal geossintético utilizado hoje no Brasil. E aí ela mostrou toda a questão de como o Brasil, né, como a geomembrana é importante para as obras de proteção ambiental, de recuperação ambiental e assim sucessivamente. Então, no caso das geomembranas aqui no Brasil, a gente tem algumas frentes, né, que a gente pode tratar sobre a fabricação. Então, temos as fábricas, e aí requer um controle de qualidade, no caso dos ensaios. Temos a questão dos projetos, dos projetistas, né, que realizam e que utilizam a geomembrana nos seus projetos. A questão da instalação é uma das principais gargalos da utilização das geomembranas, e eu acredito que o doutor Jorge vai trazer muito esse tema hoje. E todos esses três, né, nos dão a possibilidade de falar um pouquinho sobre o desempenho e a durabilidade, que vai ser abordado hoje na palestra dele, né? Sobre as pesquisas do laboratório aqui na USP de São Carlos, a gente trabalha tanto com a parte de amostras de campo, né? Então amostras exumadas. A gente também trabalha com alguns outros tipos de geossintéticos no que diz respeito à durabilidade. A gente tem, por exemplo, parcerias com alguns painéis instalados no Brasil, juntamente com alguns órgãos, né, como Furnas, o pessoal do ITA, né, da professora Delma. A gente tem alguns trabalhos muito importantes também em várias universidades, né, a gente pode citar a UNB, né, que tem muitos trabalhos sobre geomembrana, do professor N, professor Gregório. Então, no Brasil, a gente tem muitos trabalhos importantes sobre geomembranas e sobre a durabilidade geossintética em geral, né? E, ultimamente, a gente também está trabalhando com a questão dos ensaios termoanalíticos, que ele avalia a questão da temperatura, né, com algumas propriedades da geomembrana. Isso está trazendo para a gente alguns importantes resultados no que diz respeito à avaliação da durabilidade das geomembranas em diferentes aplicações. Então, no modo geral, a gente pode, com certeza, vai ter hoje, junto com a palestra do professor, do Dr. Jorge, a questão das geomembranas no Brasil e no mundo. Acho que ele consegue ter essa visão melhor, né? Porque ele trabalha em todo o mundo com esse tema. A gente tem a questão das amostras, quando a gente vai trabalhar com geomembrana, que necessita dessas amostras de referência, né? Porque a gente tem necessariamente as amostras exumadas, mas necessita dessa rastreabilidade de onde a gente exumou essa geomembrana e todo o percurso dela até a gente utilizá-la de forma a fazer uma pesquisa sobre a durabilidade, né? Então, sem a rastreabilidade, a gente não consegue ter esse avanço. E aí a gente tem, né, aqui no laboratório, esses ensaios que são de laboratório e são muito importantes para avaliar também a durabilidade das geomembranas, né? E levando em consideração também os ensaios que são realizados em campo para que essa durabilidade seja avaliada melhor, né? Como eu falei para vocês, o Laboratório de Geossintéticos eles realiza alguns cursos, e eu trouxe aqui um curso que a gente realizou juntamente com algumas empresas, como apoiadoras, inclusive a Nortène, que é o curso de instalação de geomembranas aqui da USP. A gente teve a primeira edição em agosto desse ano. Foi um momento muito importante, onde a gente conseguiu reunir os instaladores, alguns fabricantes, né? E deu tão certo que a gente vai, possivelmente, na primeira semana de agosto, ter a segunda edição. Nessa segunda edição, a gente conseguiu trazer, agrupar mais nomes importantes, né, que a gente pode citar o Ricardo Cortez, da Extra Ambiental, o Vinícius Benjamin, que é importantíssimo na área de geossintética no Brasil. Então, a gente agrupou outros nomes, né, como esses dois, para trazer um curso mais diversificado. Acredito que vai ser um curso onde a gente vai também conseguir ter apoio de outras empresas, onde a gente vai abrir para todas as empresas cooperarem, né, ou apoiarem, e vai ser um curso bastante interessante e vai se dar na segunda semana de agosto de 2023. Além desse curso que a gente tem também outras iniciativas importantes, né, como o curso da CTG, que vai ser no próximo mês, né? A gente tem também a questão da normalização das normas, junto com o pessoal da BNT, né? Então, a gente tem um importante grupo que trabalha assim, com as normas de geossintética em geral, inclusive a norma de instalação de geomembranas, né? Então, a gente tem um grupo bastante ativo sobre esse trabalho, que é um trabalho belíssimo, né? Juntamente com o professor, que é o presidente, o Schiavon do ITA, a Alejandra, que é da Nortène, né, também, que ela é a secretária, a professora Delma, e assim outros tantos nomes importantes que contribuem, sim, para a disseminação da boa instalação na geomembrana, né? Inclusive, a segunda edição da norma está sendo avaliada agora, e eu acho que daqui a um tempo vai sair, né, a segunda edição da norma de instalação de geomembranas. Então, é isso. Eu vou deixar aqui o contato, né, o meu e o do Clever. O Clever é o nosso laboratorista, né? Ele trabalha aqui desde a inauguração do laboratório há mais de 20 anos, né? Eu vou também dizer que nós estamos abertos para receber alunos de mestrado, doutorado, né, pós-doutorado. A gente tem, inclusive, vagas abertas para essas oportunidades, né, de mestrado e doutorado aqui na ESC. Lembrar que o laboratório tem uma contribuição importante com relação a vários nomes do mercado que atuam com geomembranas hoje, a Indiara, que fez mestrado aqui, a consultora, o Júlio, que fez mestrado aqui do TRI, o Vinícius Benjamin, e assim tantos outros que hoje atuam bastante no mercado, inclusive de geomembranas. Então, eu gostaria de agradecer, né, e falar que vai ser uma oportunidade única para nós. Eu até agradeço também a sensibilidade de deixar esse evento online, porque a gente vai conseguir ter bastante pessoas que não poderiam vir para São Paulo ou para, né, para algum local onde a Nortène escolhesse para fazer a palestra, então a gente vai ter essa oportunidade. E eu vou ficar aqui aprendendo e agradeço a Nortène pela parceria de sempre, né? Pelas pesquisas que a gente está fazendo, acho que a gente está até tendo alguns frutos, né? Como alguns artigos em revistas, em congressos, e eu creio que isso vai aumentar essa nossa parceria com o foco das pesquisas, né? Então é isso, eu agradeço e muito obrigado.
Obrigada, Jefferson. Muito obrigada. Agora, pessoal, eu vou passar a palavra para o Dr. George Koerner. Só que eu vou dar uma viradinha de chave, vou fazer uma introduçãozinha em inglês e vou ler o currículo dele em inglês. Então, quem quiser trocar de sala, eu vou, só para ele saber também que ele tem que entrar, né? Eu vou virar, e aí, enquanto eu estou falando, lendo o currículo, quem quiser trocar de sala para tradução, né, do inglês para o português, pode ir trocando se já não está, né? Vai trocando nesse meio tempo, tá bom? Welcome, everyone, again. It's a great honor to have you here tonight, Dr. George Koerner. I'm going to read the Dr. George CV, and after that, he's going to start his presentation. George Koerner is director of the Geosynthetic Institute. He is in charge of laboratory accreditation, field certification, and continuing education at the Institute. He also manages several research projects and has published over 300 technical papers in his 35-year association with polymers used in construction. Dr. Koerner's PhD is from Drexel University in geotechnical engineering. He is a registered professional engineer and certified quality auditor. George has received many awards over the years, the most notable being IFAIS Environmental Technologies Award of Excellence in 1995, ASC's DVGI Geotechnical Engineer of the Year in 2004, the title of STM Fellow in 2013, GMA's first Koerner lecture in 2017, and the title of ASCE Fellow in 2020. Dr. George, thank you very much for accepting our invitation. It's your time now.
Carolina, thank you so much for the nice introduction. I appreciate it. I wish I could be with you. I was in Brazil last week, and but it is an honor to be with you now. So thank you so much. This is a lecture on geomembrane durability, and the outline of this lecture is presented before you. I will give a background, design, manufacturing, storage and handling, installation, field performance. You must realize this is an entire encompassing lecture. This is a very broad lecture. I know you wanted to hear about durability, but this is the summation of how to make a geomembrane last for a long time in the field. The background of this, I apologize. This is not a Brazilian background. This is a background from the US and from Germany. These are the two most environmentally impacted regions of the world, and they obviously need the most rigorous standards. What has resulted from their years of study is this sequence of using composite liner systems with a geomembrane backed up by a clay, which seems to be very effective at reducing leakage. Geomembranes are used in many different applications. tunnel linings, dam proofing, surface impoundments, aerobic and anaerobic digesters, a whole host of properties related to water, canals, reservoirs, tunnels, and then in solid waste, both in the liner systems and in the cover systems. So geomembranes are used throughout these systems. And I submit to you, you need to have this umbrella policy of a good design, quality materials, accredited testing, good installation, quality assurance of the installation, leak integrity surveys before commissioning the facilities, and then careful operation and maintenance. Please realize membranes are the only geosynthetics which are governed by regulations. This is a regulation-driven industry, which is quite a bit of a change from the rest of the geosynthetic and polymer in construction business. The first thing I'd like to talk to you about is design and their stability, of three concerns: of actual liner systems, of the waste itself, and then of the cover systems. And these are failures that I'll show you. I show you these failures not for shock value, but for truly an educational perspective. Multi-loan slopes require that you have the tensile capacity of the geosynthetics, as well as having the interface friction of the material. This is a failure of a liner system out in California. It was in a valley fill, and the entire system translated 100 meters down slope. It was quite a catastrophic failure. The case history showed that the triggering mechanism was the weak interface between the geomembrane and the other geosynthetics, and the failure resulted at this interface. When you have multi-line slopes, you need to know the interface friction angle of all the different interfaces, which is critically important to the design. Requires shear strength and wide width tension. This is the result of this failure, was the evolution of textured geomembrane. Stability issues of the waste mass itself can be important, and this is particularly important when fine-grained materials or sludges are landfilled. It's also important for high landfills, steep landfills, and canyon configurations. This was a very dramatic failure which occurred up in Maine. The owner got greedy and excavated the stiff clay at the toe of the slope. This is a cross-section of the failure, which was actually 6 individual failures of circular arc failures going through the cross-section. Here you see the circular arcs 1 and 2. This is the circular arc 3, 4, 5, and 6. And this is what it looks like from the fill. Please, you cannot discuss durability of the geomembrane if you have these sorts of design issues or stability issues. This is a very dramatic failure and was a result of the owner-operator being greedy in the regards. We did the analysis of the slope, and this was certainly a rotational failure. The triggering mechanism was removal of the stiff clay at the bottom of the slopes. Far and away, the most stability concerns we have is with the landfill covers. This is typically a thin veneer of soil, which is placed over top of a covered geomembrane. The issue here is volume is money. So the steeper you make the side slopes, the more volume you can place in the hole. Obviously, the more challenging the veneer stability. This case history was on a relatively shallow slope, a 3-to-1 slope, which is at 18.4 degrees. The failure occurred between the geotextile and the geomembrane. In this particular case, we knew we had a problem because the membrane collected itself on the way down through the cross section. From a stability analysis, it was very obvious. The geomembrane against the nonwoven textile has a peak friction angle of 20 and a residual friction angle of 16. As you move from 20 to 16, you will see the factor of safety goes below 1 at 17 degrees, so critically important. Commentary on this, you need to know the shear strength of many different materials. Textured material will help you in veneer reinforcement. Stability analysis needs to be conducted during construction, and stability is a long-term challenge in a changing environment. When you get steeper than 3-to-1 slope or 18.4 degrees, you really have to sharpen your pencil and do a very detailed analysis. Don't apologize for being conservative. You do not want a failure in design like this. There's no discussion about durability of a geomembrane once you have failures like this. Now let's go into manufacturing. I submit to you that Engie Nortène has just extrusion, at least from what I've seen. These are typically non-reinforced polyolefin materials, which are produced in a factory, which is a beautiful facility. If you get the opportunity to visit, it truly is a nice facility and a world-class facility. The geomembranes are formulated with mostly resin and very little additives and carbon black associated with them. The polyethylene, this is what it looks like in about rice-sized kernels. It has different densities. Density is related to crystallinity. The more crystalline the material, the more chemically resistant the material. You then add additives as well as carbon black to the formulation, and these additives are for different reasons. They're for processing aids. They could be for a UV absorber. They could be for stabilizers or inhibitors. I should caution you that there is an additive which will compromise the durability of the geomembrane. It's very inexpensive. It's calcium carbonate or talc. It can be added into the formulation in anywhere between 5 and 10%. This is a cost savings for the manufacturer, but it will compromise the long-term durability and probably increase the mechanical properties in the short term. This carbon black and additives are married with a carrier resin and then introduced into the hopper of the extruder in the form of a letdown, blending the master batch with the actual resin. You must discuss regrind or rework of material. GRI GM 13 and 17 allow for 10%. This is edge trim of the material. This is material that has not left the factory. This is very different than reclaimed or recycled material. This is problematic, and there's absolutely no post-consumer recycled or reclaimed material which is allowed inside of GM 13 and 17 materials, and for the reason being that it's not traceable in this regard. The hopper of the extruder are typically anywhere from 100 millimeter diameter to 200 millimeter diameter. It's made of one of two ways, the first of which is flat die or cast line, and the second line is known as a blown film line. These techniques produce geomembrane somewhere in the neighborhood of 10 meters in width. They're very heavy on rolls, and these rolls have dedicated straps associated with them for lifting. There are 3 different methods for making texturing: embossed rollers, hot particle impingement, and nitrogen expulsion. Each has its pros and cons associated with it. The manufacturing can go wrong. Issues that you need to be cognizant of are foreign particles, moisture, blooming of the AO package. If you put too much AO package in, you can have bloom of the material. You can have agglomerates or tiger striping of the texturing material. You can have an issue with stress cracking. If the material is prone to stress cracking, you can have a catastrophic failure of the material, as shown in these 4 case histories. Stress cracking is typically challenged with an ASTM method, ASTM 5397, which is nothing more than an accelerated aging test in a surfactant, a wetting solution. You're looking for cracking in the notch material, and you would like to see its resistance over time. In addition to that, you also need to have the geomembrane resistant to the environment that it's exposed to. This is typically a 90-90 type test. You do not want your geomembrane reacting with the waste. And this is particularly problematic when you have chlorinated organics, BTX compounds, or solvents in this regard. There are checks for this. The 2 different checks are laboratory immersion and field immersion. For geomembranes, it's ASTM 5747 is the test method. Typically, what you're seeing when the material ages is a decrease in elongation, an increase in modulus, and an increase in strength with respect to time. You will check these at 30-day increments after the exposure, 30, 60, 90, and 120. The typical, the 90-day exposure is the challenge where you'd like to see if there is reaction to your material. There are many researchers which have given their opinions on this reaction or not. You see 3 different ones from the Encyclopedia of Plastics, A.D. Little, and then Bob Koerner's book, Designing with Geosynthetics, gives the most comprehensive look at this. As far as long-term durability, though, this is the test method that is most often discussed. This is an 18-year study which was conducted at the Geosynthetic Institute. And basically, this is Arrhenius modeling using geomembranes. This is the reaction vessel. The reaction vessel is in an aqueous solution. It's heated. In addition to that, it has a large compressive normal pressure simulating a landfill. The temperature thermocouple is in the bottom in the sand. The geomembrane is strapped in between the flanges, and then you run this in quadruplicate. The quadruplicate is because it's in 4 different temperatures. So you have 4 different temperatures you're operating at. Pardon me. You're generating curves like this, which are plots of property versus time. You have it at 55, 65, 75, and 85 degrees C. You're seeing 3 different portions of the curve: antioxidant depletion, induction time, and then the half-life property. Once you do the analysis for the geomembrane, you are taking the slope of the inverse temperature plot, and this is known as the reaction rate. Knowing the site-specific temperature, you subsequently can get the lifetime prediction of these geomembranes. After 18 years of research, this is the work that we've done for HDPE. It was conducted on 1.5 millimeter HDPE. The antioxidant depletion is between 50 and 150 years. Induction time, 20 to 30 years. And the half-life varies greatly. GSI has that around 500 years for a total of somewhere between 300 and 1,000 years of lifetime exposure. You then must have to go to the site-specific temperature. Most landfills are in the neighborhood of 20 to 30 degrees C. So your longevity is between 300 and 700 years. But you can see as the temperature increases, the longevity of the material decreases for site-specific temperatures. With all that said, you must handle and store the material properly. This is quite significant in the field. You must have the proper equipment to move the material in the field, and please realize it's quite heavy. It's a different situation when the material comes in containers from overseas. You can no longer use straps, but you have to use a stinger bar. It's unacceptable to store the material like this outside. You would compromise the material significantly if you do not handle it properly. Subgrade preparation is also important. The material has to be prepared to receive the geomembrane. Here you have fine grade, removal of the stones, anything bigger than 10 millimeters is not allowed. Then you'll roll the material flat with a vibratory steel wheel roller. People asked, will this material last? And my comment is absolutely not in these conditions. There's a lot of stress concentration here, and this material has no chance to live for several hundred years, covered or exposed, based on its improper installation. You're very interested in puncture of material. Obviously, if you compromise the material from below, it can no longer function as a barrier. To bring this point home, this is data from over 300 sites. You'll see that the vast majority, 70% of the problems were related to puncture of the material. There's no discussion about durability if you have these issues with puncture. To get away from these, you might use a tougher geomembrane. You see HDPE, which is drawn in the blue curve, and the linear low density material is drawn in the green curve. You can see a change from about 12 millimeter cone height all the way up to about 80 millimeter cone height with just the change of the geomembrane. So the toughness of the geomembrane is critically important. In addition to this, the truncated cone test can be adapted for geotextiles, and these geotextiles are used as puncture protection materials. And you can see with HDPE, you can change that critical cone height from around 20 millimeters all the way up to about 50 millimeters if you protect it with a needle punch non-woven. Field placement is critically important, and you'll need the designer to help you in this regard by making long longitudinal cells. The geomembrane is spotted at the edge of the facility, and then with a bunch of human power, you'll move the material into position. You'll be helped dramatically with long longitudinal cells where you can seam across the material and work towards the sump. Backfilling is also important. You can puncture the material from above as well as below. Above, you typically have a big needle punch non-woven, and then subsequently a leachate collection removal stone is placed on top of it. It's placed in fingers, so you flatten the material out. You cannot entomb these waves. Waves are stress concentrations, which will be problematic to the material over time. You can get away from waves. Backfilling in the coolest part of the day is also very good. Various concerns with entombed waves are stress concentration, which lead to durability problems, many dams, damage during backfilling, and concern over intimate contact. The material cannot look like this when you're installing it. This is a tragic failure and no intimate contact between the geomembrane and the clay. This is how the site should work with staged construction. The material should be press fit or flat on the underlying material. To achieve this, Bob Koerner has created this table with method advantages and disadvantages. These are the sequence you could use. You can use white material, you can use textured material, you can also use scrim reinforced material. The membrane is not the only thing of concern. You will need to seam the material out in the field. And here you should use the best available technology for this. Extrusion weld is a terrible seam. This is the worst type of seam there is. You have to do this for detailing, but please do not use this for production welds. It's very labor intensive, it's very detailed, and certainly can be problematic in the field. The thing you would like to use is wedge welding, which can be very much automated. You also have a non-destructive test with this. This was all generated by Pfaff, originally from Austria. The patents have worn off on it and it can be used. This is the wedge of the wedge welder. You can see the nip rollers, the bottom sheet and subsequently top sheet. There are many different manufacturers of these wedge welders, and certainly it's the best quality seam we have in the field. You typically are making 2 seams with an air channel test, a non-destructive test in between, and this can be checked or examined over many hundreds of meters. You will do trial field seams in the field, and these trial seams will be to evaluate the personnel and also to evaluate the equipment. They'll be checked out in the field. Please realize in the States, we are cutting destructive seams in the material, and this is 1 meter of wedge welding that you're replacing with 3 meters of extrusion welding. This is not a very good exchange, and please do this judiciously so you don't run into problems. Destructive seam test. How do you get away from destructive seam test? You do that by non-destructive testing, the method of attributes and control charts. You might want to place an edge trim of protective material so that your edge is smooth, clean, and dry. The 4th thing is you might want to use an automated welder. These welders control temperature, pressure, and speed, so you know the parameters at which your seams were created. You might want to use non-destructive testing, and with all this information, the facilities have gotten huge. Here you see a massive reservoir in the southwestern portion of the United States. Here you see a very large reservoir for potable water up by the Great Lakes. And here you see a disposal area of over 100 hectares, which are used with geomembranes. So there's quite a bit of trust in geomembranes. They've proven themselves to be effective over the years. These facilities are all commissioned with leak integrity surveys. These surveys, there are many of them. There are 5 different methods within inside ASTM. It's basically controlling the facility before you put it into service. With all that said, the proof is in field sites. And this field site, which I'm going to show you, is over 30 years old. This particular site excavated material which is placed 31 years. This is the excavation, and it's due to a gravity feed system. They removed all of the geosynthetics, and we tested them in the laboratory. The geosynthetics look beautiful after 30 plus years. The geomembranes were in excellent shape. The nets and the textiles were all functioning well. Here you see the comparison of this material, which was HDPE, with GRI GM13. We even checked the seams, and they behaved extremely well. The liner performance in both the primary and the secondary is aging very well. Slight decrease in stress cracking and OIT. The seams are performing well. And the most important thing is the client is extremely happy. These geomembrane lining systems are thin. They're very successful. And to prove that to you is a set of data from 200 landfills throughout the world. And we see that leakage rates are well below 70 liters per hectare day. This is also proven in the state of New York, where all of their landfills are public record, and this corroborates the data that these facilities are performing extremely well. So the recommendation for this lecture is that it's a quality system approach for durability. You need a good design by a professional engineer. You need quality materials like GM13. Engipol Nortène produces these materials. It's accredited testing and possibly a CE mark. Best available installation. I hope you know about IAGI and the CWT. I talked to Carolina last week and she said this is coming to Brazil soon. Quality assurance, we're all better when we're looked at. And then leak integrity surveys before commissioning the facility. Obviously, operation and maintenance is key, but this will lead you to a durable and long-living material. Thank you so much for your participation. I hope the lecture was interesting. And if you have any questions, I would gladly answer them at this time. Thank you so much for the opportunity.
Thank you, Dr. George. It was a very good presentation.
Was amazing. Yeah.
Yes. The questions will be answered after. Okay, I will send you the questions. You can answer, and after that, you'll be sending to the people who ask. Okay.
Certainly, I'm happy to do it. Thank you so much for the opportunity.
Thank you. Roberta, então a
Sim,
gente finaliza?
sim, vamos finalizar sobre as